Right, this video is going to be about properties of waves practice problems. Though, of course, many of these are going to have to do with our speed equation for waves, which is, again, speed is equal to the frequency times the wavelength. All right, what is the speed of a sound wave that has a wavelength, wavelength of 2.00 meters and a frequency of 170.5 hertz? All right, well, my speed, which will be in meters per second, is going to be my frequency of 170.5 hertz times 2.00 meters. If I plug that into my calculator, 170.5 times 2 gets me a speed of 341 meters per second. A wave traveling in the water has a frequency of 500 hertz and a wavelength of 3 meters. What is the speed of this wave? Again, our equation is going to be V equals F times wavelength. My frequency is 500.0 hertz, and my wavelength is 3.00 meters. So therefore my speed is 500 hertz times 3.00 meters, and that gets me a speed of 500 times 3, which is 1500 meters per second. That is the speed of that wave. The lowest pitch sound humans can hear have a frequency of 20.0 hertz. What is the wavelength of these sound waves if their wave speed is 340 meters per second? So again, let me remind myself, my equation is V equals F times wavelength. All right, and I have a speed here of 340 meters per second. My frequency is 20.0 hertz. I can change this equation so that I'm solving for wavelength, where now it'll actually be V divided by F equals wavelength. So if my V is 340 meters per second, and my frequency is 20.0 hertz, I end up getting 340 divided by 20, a wavelength of 17, and that is in meters, because that is a length of something, a distance, and that's an M with a dot for meters. A sound wave with a frequency of 100 hertz travels in water with a speed of 1500 meters per second, and then travels in air with a speed of 340 meters per second. Compare the wavelength of the sound wave in the water in comparison to the wavelength of the sound wave in air. Okay, so let's remind ourselves, V equals frequency times wavelength. So let's just say in water, I'm solving for wavelength. So let's just say my speed in water, I don't know why it's doing this way. My speed in water is going to be equal to my frequency times my wavelength in water. And again, if I'm solving for wavelength, I can do my speed divided by my frequency equals my wavelength. So my speed in water was 1500 meters per second. My frequency was 100. I end up getting my wavelength of 15 meters, and that is my, I don't know why I put it in parentheses, but that is my wavelength in water. Similarly, I can solve if my speed in air is equal to my frequency times my wavelength in air. I can also do my speed in air divided by my frequency equals my wavelength in air. So my speed in air was 340 meters per second. My frequency was again 100, hertz. Therefore, my wavelength in air is 3.4 meters, which is my wavelength in air. And if I wanted to, I can take my 15 of my, which is my wavelength in water, and divide it by my 3.4, which is my wavelength in air, which gets me about 4.4, and that is the amount of times that the wavelength in water is greater than the one in air.